So now in recent videos we looked at how the voltage at the base of an NPN bipolar junction transistor sets the voltage at the emitter if there's resistance right there, other than it's about 0.6 volts less right there. So that will set that voltage. That means that when you get the supply to the collector, it's going to set the current based on that voltage divided by the resistance. Pretty straightforward. Now we have an LED added to the circuit. Doesn't matter, we got that voltage across the resistor, and therefore we're going to get the same current, as we'll see. So I'm not going to use a 500 ohm resistor, though I'm going to use a 510 ohm resistor. We're going to have slightly less current, but we're going to see that it's pretty consistent. So to get the 5 volts now, we're going to come back to the component of the last video, the zener diode. When a zener diode is reverse bias, so you can see the black band is towards the more positive side up there of the circuit. Then through the resistor there, current will start flowing once it gets above 5.6 volts. So it's not exactly 5.6, but pretty close. And it changes a little bit with how much current's flowing through it. But in any case, that voltage is going to build up across it. Any voltage higher, current just goes through the zener diode. So it holds it level pretty well. That's going to the base. So 5.6 volts. That's why a lot of zeners have a 0.6 volt above, you know, like 5.6, 9.6 or whatever, because they realize a lot of times you're going to the base of an NPN bipolar junction transistor and you're going to lose 0.6 volts. So you end up with that original number before the decimal point. So now we have the meter set to measure milliamps of current. Make sure it's set to measure as much current as you're going to measure. And we're going to complete the pass. So we're bypassing the LED. That's why it's not lighting up. But there you can see 9.78. So again, we got 5 volts across the current setting resistor. It's 510 ohms of resistance. So a little less than 10 milliamps of current right there. But there you can see through the LED, we have the same current. Although it might show just like 1/100 of a milliamp different or something, practically the same. So that was at 9 volts. Now we can go up quite a bit. The way we have this set up, we're going to stop at 13. That might be about the max, I'm not sure. But in any case, voltage went up quite a bit. There you can see same current. It probably will be just a speck higher because with more voltage, the transistor heats up more, and we'll probably start conducting a little bit better. That's one problem with transistors getting too hot, thermal runaway. But we're pretty safe here. But there you can see we had, even with the voltage difference at the supply, it didn't matter. Our voltage is set by the zener diode, which doesn't depend on the total voltage at all, just a bit on how much current is flowing through it.